Here's the answer for day 4, problem 1. Evaluate the 6 trigonometric functions at the real number t equals pi. So first we need to list these trig functions. Cosine of pi, sine of pi, tangent of pi. Now the reciprocal functions, secant of pi, cosecant of pi, and cotangent of pi. If we use a unit circle to find these values, we can use ordered pairs from the unit circle. Cosine ends up being the x-coordinate of a point on the unit circle. Sine is the y-coordinate. Tangent is y divided by x. Secant is 1 over x. Cosecant is 1 over y. And cotangent is x over y. So here are our 6 trig formulas that will find us these functions. Our next step is to use the unit circle in the back of the textbook and find where a pi radian angle hits the unit circle. And it hits on the far left of the unit circle. A pi radian angle is equivalent to 180 degrees. If you start at 0 and swing 180 degrees around the circle, you'll end up going halfway around and end up at the leftmost point of the circle. That will have the ordered pair -1, 0. Remember, the first number is x, the second number is y. So since cosine is the x-coordinate, the cosine of pi is -1. The sine of pi is the y-coordinate, which is 0. If you were to take a calculator and put it in radians mode and type the sine of pi and hit enter, the calculator is just going to say 0. For tangent, we need to go y divided by x, so that's 0 divided by -1, which is equal to 0. Again, on a calculator, if you typed tangent and pushed pi and then hit enter, the calculator would tell you that the answer is 0. 1 over x is going to be 1 over -1, and that turns out to be -1. 1 over y is 1 over 0. We have to write undefined for that one. If you try doing that one on a calculator, it would say error. And the last one, x over y, is going to be -1 over 0. And again, we have to say undefined. So here are our values for the 6 trigonometric functions for the angle pi radians. Day 4, problem 2. Find the following sum. Our expression is I squared plus 1, and we're going to sum that expression from I equals 1 up to I equals 5. So let's start by substituting in 1 for I. We have 1 squared plus 1. That's our first term of the sequence of numbers that we're summing together. Plus, now put in 2 for I. We have 2 squared plus 1. There's the second term of the sequence of numbers we're adding together. Plus 3 squared plus 1. Plus 4 squared plus 1. Plus 5 squared plus 1. Each of these expressions in the parentheses is one of the terms of a sequence of numbers. We want to add this all up. So 1 squared is 1, plus 1 makes 2. 2 squared is 5. I misspoke. 2 squared is 4, plus 1 makes 5. 3 squared is 9, plus 1 makes 10. 4 squared is 16, plus 1 is 17. And 5 squared is 25, plus 1 is 26. Notice that what we have here are numbers that are all 1 more than a perfect square. 2 is 1 more than 1, 5 is 1 more than 4, 10 is 1 more than 9, and so on. Let's just add these up. 2 plus 5 is 7, plus 10 is 17. 17 and 17 is 34. 34 plus 26 makes 60. So the final sum is 60.